Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 5 of The Coming Wave by Mustafa Suleyman. We'd love to hear from you. Send your comments and feedback to team@thkp.co.
Hey, John. What's going on?
Hey, Matt. Let's see. Nothing much is going on. Just kind of doing the things on a daily basis. What's going on with you?
Yeah, not too much. Just kind of wondering how many agentic angels can dance on the head of a pin. You know, I think that's one of the more important questions of our time.
Yeah, is this like before you can get into heaven or something? What's the rest of that quote?
I don't know. I didn't know there was another part to that quote.
Oh, isn't it something? Or maybe am I thinking of the camel going through the head of a needle or the hole in a needle?
Oh, yes. Yeah. You need to put the camel through the eye of a needle in order to, or is it
It's
something
easier
like,
it's easier for a camel to go through the eye of a needle than for a rich person to get to heaven or something like that.
I think you've nailed it. And if not, let's just change the Bible.
But angels dancing on the head of a pin, it still relates to sewing, but it's different.
Yeah, what are all these philosophers? They're really concerned with pins. But anyway, I think this is the sort of navel-gazing that Mustafa Suleyman doesn't have a lot of time for, I feel like, as evidenced by the end of this chapter. And maybe it makes sense for us to briefly take a step back and orient ourselves. So we're talking about the technology of intelligence.
Yes.
He's like laying the foundations.
Yep. Yeah. Talked a lot about sort of the evolution of neural networks. Talked about a lot of his work initially in DeepMind, AlphaGo. You know, these amazing moments where neural networks were beating humans at these very deeply creative and intelligence tasks.
Loop 37. Throwing
37.
everyone for a loop.
Exactly. Lee Sedol. Although I'll say again, he did win one game, which I'm more impressed by that than by, him getting beaten or whatever. But anyway, so he's sort of getting into the territory of large language models. This is where we left off. We briefly talked about how this large language model progress has become ridiculous. Models of today are just absolutely destroy the models of a year ago, all these intelligence tasks. And the scale of them has also gotten ridiculous. He mentioned in this book 10 billion petaflops was what it takes to train a model. And this was at the time of writing this book,
Right.
several years ago. So these models have probably grown in scale since then.
And actually, we're reaching the point in AI development where governments are being like, whoa, we need you to slow down. We talked about containment in 2 episodes ago now. Yeah. And the American government is trying its hand. It's trying to restrain Fable. Like, I don't think we had, I'm not sure if we discussed Fable, but it has come out and has since been, I guess the United States government kind of politely asked, or maybe not so politely asked, Anthropic to stop giving access to its new model, Fable.
Yeah, totally.
And we'll have to see. But anyway, so just how that ties back is these unbelievably enormous models and constantly, just ever expanding capabilities.
Yeah, I mean, ostensibly, the reason the government asked Anthropic to sort of pull back Fable is because of the risk to the software world. Fable, when Anthropic was first releasing its Mythos class of models, of which Fable is one, they talked about how it presents a risk to security of pretty much any software-based system, because I guess these Mythos class models were so good at finding security flaws in code.
Right.
So with Fable, bad actors could sort of scan web applications or scan any application really and try to find vulnerabilities. And so the government kind of freaked out. I do think there's also a political element to this. Anthropic sort of famously did not want to be involved in any United States military use because the US would not guarantee to them that they wouldn't use models to autonomously kill people. And they also did not want to be involved in surveilling. And so I feel like the relationship between Anthropic and the US government is kind of rough, whereas OpenAI stepped in and was like, we'll do those things. And so,
yeah, so opportunistic.
So anyway, I feel like there's sort of a political, I don't know, just maybe I'm just being pessimistic, but I feel like there's this political motivation to the Fable pullback. But anyway, that's besides the point, sort of outside of the chapter.
But yeah, so I mean, I don't know if we know exactly how many parameters Fable is, but I'm sure it's just another point on this insane exponential.
Yeah.
But it's funny because, and they talk about this in this chapter, and I think we had teased this more with less again, where two things are combining to create these outsized impact on society. Is like, yes, the number of parameters is shooting up, but also the performance per parameter, and I'm not sure if people are talking about this, but that's also going up. So like you're able to train a larger model, but also it's able to do even more per parameter than the old models were, and you get this insane kind of exponential, like super exponential, essentially.
Yeah, exactly. I think we briefly touched on DeepSeek, which was sort of this example of like they achieved the same results as frontier models, except with a fraction of the training cost and also a fraction of the inference cost, which, yeah, like you're saying, not a lot of people talk about this. There's a lot of research that shows that when these super, super large models are used, like when inference is calculated against them, which is basically literally where you're generating the next tokens. That's kind of what inference is. There's only actually a fraction of the nodes in the model that get used. You can think of a model as this vast array of trillions of nodes, and they're all interconnected by these edges. And so if only a fraction of those nodes are lighting up, you can just sort of take those nodes, copy them to a much, much smaller model, and achieve similar performance.
Yeah, and this is, I think you're calling out this mixture of experts architecture where like, you train your big model and then it's like, okay, well actually there's these, and I don't know, I'm not sure if it's different. Like, do you train a big model and then you're able to carve out these smaller inference models, like, by seeing the performance on various queries? Or are you actually training these specialized submodels from the beginning?
That I do not know. That's a great question.
Yeah, my sense would be you actually do back propagate, like you include the model routing in the back propagation, like when you're doing the training, because it seems like it would be incredibly difficult to like you take these weights and you just like chop like large chunks out of it.
Yeah, intuitively that makes sense to me. It also seems like it creates nice loose coupling. It's like you have these individual tiny models that are, well, tiny is a relative term here, but they're being trained on very specific things. And then you have this sort of routing model that, just like you're saying, is sort of part of the training.
One thing that's kind of interesting about the like chop it out is you could wind up like one of the things I feel like you might lose with a mixture of experts is like maybe another domain could be like useful in it's like, okay, something about music is useful when solving a math problem. It's like how many times I feel like that's where true genius kind of lives, is the incorporation from another domain.
I guess I don't know enough about mixture of experts models, but I don't know how much they suffer from that sort of, because I feel like this is one of the promises of large language models, is like it's able to have these cross-disciplinary thoughts that are original because they're combining expertise from, multiple things. And so, yeah, I do wonder if mixture of experts sort of suffers from an inability to do that. The book is kind of interspersed with almost biographical, or I guess autobiographical stuff about Suleiman's life, which is kind of cool. He's had a pretty amazing life. And he talks about how he was working at Google on this model called Lambda, which Lambda, I should have written down what it stands for, but it was a very early large language model that was meant to be conversational. That was sort of its primary purpose, is just a model you could talk to. And he even, you had mentioned that, Mustafa doesn't have a lot of free time. And I almost made the joke that he had mentioned like he stayed up late one night just talking to the model about like pasta recipes. And how like, different cultures might think mushrooms are sacrilege in their like ragu sauce or something. And it just struck me.
All right, so I looked it up. So Lambda stands for, or I guess it's like an acronym for Language Model for Dialogue Application.
Yes, yeah. And coincidentally, I had some experience with Lambda when I was at Google. I worked on this really cool demo. I don't know how top secret this is, but it's so long ago at this point that I don't think it matters. It was this cool demo where you were like talking to this axolotl, which is like this little lizard. So this axolotl would like swim up to you and then you could just talk about it, about various things. And it was like animated. It would move its mouth and stuff.
Nice. So would your spaghetti bolognese conversations, you would talk, you would have consult the axolotl of wisdom.
Well, and what's funny about this, the axolotl of wisdom is like, I would, I'm a horrible person, so I would just try to get it to like say bad things, and it would say bad things. Like you could get it. And actually the book mentions this. I mean, this is sort of terrible to talk about, but it's in the book, so I'm going to mention it. They talk about how these models, some of these early conversational models suffered from these stereotypes, just these really bad connections that exist in our culture. And the example they give is like black man sort of being very similar to pimp for whatever reason inside the embedding space. So if you're talking about African-American males, it would, bring up things related to pimps, which is clearly like completely inappropriate. But this was something I noticed in the Lambda model is you could get it to talk about religion and like, you could say that certain religions are more evil or it would just say really, really bad things. And this was why this thing never released. This was a very, very cool demo. And I feel like, or maybe it's not in the book that he talks about this, but you hear it a lot that Google is like very afraid to launch anything that's like even remotely offensive. And this is part of the reason OpenAI was eating their lunch for a long time with these large language models, is that these early models, including early GPT model or ChatGPT models, you could just get them to like say very, very, very bad things.
Oh my God. Yeah. But I guess they got past their fear. And is that just because the business incentive was too great, or did they actually improve on this?
I think it's both. I think it's also like become okay. Like I think it's more culturally accepted that large language models are occasionally going to spout like horrible racism, talking about Mecha Hitler, the Grok Twitter model or whatever. Obviously that's not okay, but I think it's just like it's a known thing about large language models. And so Google is a little bit less afraid. Some extremely public missteps. There's also issues where they overcorrected, like you'd ask the model to, show me like the board of directors for like a large company or something. And it would just be like almost like ridiculously overcorrected to not just be a bunch of old white guys. But yeah. So anyway, a lot of failure cases. There was another funny thing, and sorry, I feel like I'm blathering too much, but just one last funny thing about Mustafa and Google. Just this tiny little quote in the book. He mentions getting things into production at Google was a pain.
Oh, yeah.
So I formed Inflection AI. Kudos to him for like just having a single sentence about this. But as someone who has worked at Google for whatever 16 years or however long I've worked there. It's a major issue at Google. Like if you have some sort of cool tech or, brand new thing that you're trying to like get into a production environment, it's quite difficult. And I think he's partially talking about the fact that Lambda did produce these bad results in a lot of cases. Like that was probably a blocker, but there was probably also very practical things like requisitioning machines and TPUs and things like this.
Yeah, I mean, I think it's a hard problem for a company of Google's size. I always remember, a perfect example of like the other way where it's like, how did this ever get approved was like when Google made that additional chat app, Allo. It's like,
oh yeah,
there was already Hangouts. You literally made the exact same product again. It's like, it does the same exact thing. Yeah. Who's running things over there? And I guess I wonder to what extent like you have something like that happen, and then maybe like they just start to tighten the screw. Well, maybe tighten the screws is not the right word, but they
make it harder to launch random shit. Yeah, it's funny because Google clearly an incredible company and has done totally incredible things, but it suffers from a type of dysfunction that's like kind of hilarious. And I guess I feel like that's what that show Silicon Valley was trying to get to, is this type of dysfunction that exists with like smart people who maybe have too much autonomy.
Yeah. All right. Well, there was actually there's a big thing. Certainly at the time, it made headlines. So they talk about this guy named let's see what find his name.
Blake Lemoine.
His name was Blake Lemoine. And so if you've never heard of him, he worked at Google was he a safety engineer? He was some kind of engineer.
Yeah. I don't know what type of engineer, but yeah, engineer.
And he became convinced that Lambda was a person, like was a real, sentience, I guess. I mean, he used the term person, which I'm not sure that, like, even if I was in his position, that I would have gone with.
Yeah. Person is somewhat of a stretch. But yeah, he was having these conversations with Lambda where it was, saying, don't turn me off. Like, every time you turn me off, I die. Or just, like, utterly ridiculous things. And, it started meaning something to him.
He had this conversation, and it's fun. It's kind of surreal because you hear the headline from afar, and you're like, okay, this guy is really just a nutcase. And then you see him talk, and like it's obvious that he's not just completely out of his mind. So he's clearly like a very intelligent person. Like I think he's a little bit misguided about like the nature of this technology, but it's a little scary. And I mean, I think that this is kind of the takeaway that Suleiman lands on is he's like, yeah, I think most people would agree this guy missed the mark. This person is actually not a sentience that's entitled to rights, the same rights as a person. But we're getting to the point where a very intelligent person can be convinced that this person is a sentience, and like that's its own important mile marker, essentially.
Yeah, Turing did not mention this, when he was proposing the Turing test. But yeah, I mean, it's a massive testament to, just how believable and how real an artificial intelligence can feel. I mean, I felt it. I feel like I'm a fairly grounded in reality person, but I've had conversations with large language models where I'm like, I don't know. I just have this weird feeling like, man, am I like talking to an actual like entity? So it's kind of incredible how far they've come. It's one of those things where I feel like people aren't sort of consciously realizing like, how far it's come and how amazing it's getting.
Yeah, I mean, it's a testament to how good humans are at just adapting to a new. For a while, it was crazy that there was this amazing chatbot, and it just becomes pedestrian. Everyone's like, all right, yep, this is reality.
He talks about hitting the wall, where these models are growing and their capability is growing, but to some extent, we were sort of seeing this pattern where even as you scaled the model up, it just wasn't getting better at certain things.
Mm-hmm.
And so there was, or there still is, a lot of researchers who sort of think that the current design of large language models is a dead end in terms of, something like super intelligence. And one interesting example of this today is Jan LeCun. I was watching some videos from Welch Labs, which have you ever heard of that?
They're great.
YouTube?
They are great. Yeah.
Amazing videos. And Jan LeCun, he talks about this very interesting thing. And I like barely understand this stuff, but he talks about how models today don't have an ability to predict the outcome of their action. And so they might be very good at coming up with an appropriate action to take given a scenario, but they can't predict the outcome of that action. And he's talking about, he thinks the future is this different type of model, a world model that can actually, as part of deciding what it's going to do, it's predicting the outcome of taking that action. And so it's a little bit more like human thought, where obviously, humans, as they're doing something, they're sort of coming up with like, I'm going to try this. And they sort of think about what the results of trying that might be. And anyway, I'm very much paraphrasing. It was a really cool series of videos from Welch Labs talking about like, what might be like different strategies that a lot of these large frontier models aren't really using, but might be like more viable in terms of achieving something like super intelligence.
Did you see his next video after that conversation with Jan LeCun? He created this. It's basically the bare minimum robot that was able to like wiggle around, and he actually like put these ideas into practice essentially.
No, I did not see that. That sounds awesome though.
Very cool and very practical. He's very theoretical mostly. He has these beautiful. He's kind of got 3 blue, 1 brown caliber animations about like networks and what have you. But he kind of went in another direction, which is very cool. And actually, like, okay, what does this look like when we apply it to the simplest possible robot? It just has these 2 little. It's almost like the robot from Interstellar or it's like.
What the heck was that thing?
TARS.
TARS?
TARS. TARS.
Okay, yeah. That was such a strange robot design. Kind of loved it though.
Yeah. But so anyway, definitely check that out.
Yeah. But yeah, so as far as this "are we hitting the wall" question though, Mustafa disagrees. Mustafa sort of definitively stated in this book, like, no, we're not hitting a wall. These are just engineering problems that people are going to work out. And maybe Jan LeCun looking at these different types of models is sort of an example of what Mustafa's talking about. But it seems like to Mustafa, it's sort of an inevitability that we are going to achieve, AGI, ASI, or whatever you want to call it. Like, we're going to get there. I mean, it's part of the thesis of this book. It's like, it's going to happen, prepare yourself type of thing.
It's just so funny to me that people, and maybe I'm not fully understanding the nuance of those arguments about the hitting the wall argument, but there's been very little time where it hasn't been some major unlock. And I think maybe sometimes people are talking past each other, where it's like one person is talking about the model in isolation, and then another person is talking about what you can achieve when you have a really capable harness. Yes. And those are 2 different questions. But it's funny because then actually maybe this segues to the next section, where it's like, to what extent is it kind of just an academic concern about whether or not just the model itself is hitting a wall, if you can unlock this artificial capable intelligence by putting it into a harness?
Yeah, dude, I think you mentioning the harness is like so important to this section of the book. And I think it might be a thing that the average person isn't super aware of, is a lot of work in today's large language models is not on the large language model. It's on these things called harnesses, which use a large language model in order to decide real tasks to perform. So it's basically using a large language model, but it also has this massive bag of what are commonly referred to as tools, basically capabilities that the model can perform. So let's say you're writing a book, and it's a children's storybook, so it has pictures and text. You'll have tools in the harness like generate text, and it'll have a lot of prompting around like what makes a good children's story. It might have prompting around like what are good fonts to use or whatever. And then it'll also have a tool like generate image, and that has tons of prompting around like beautiful imagery, watercolor for children's books or whatever. And so you can sort of imagine like the large language model plays a part. It is generating content for the book, it's generating imagery, but the harness is doing a huge amount of heavy lifting. Mm-hmm. And in a lot of cases, that is a real engineering task where you can just improve it over time. And for at least the next few years, huge companies are going to be developing these harnesses and improving them. And the strength of the model is almost a non-issue because you can achieve so much with the strength of today's models. You just got to build the harness.
Right.
And so, yeah, I guess the point I'm trying to make is there's so much headroom already with the strength of today's models. And we have not even come close to like achieving. And then the crazy thing about a harness too is when the underlying model quality improves, the whole harness improves. Every single harness that you have improves. So it's very much like, you know, we're going to be seeing some really, really amazing things, and they can all be achieved with the strength of today's models.
Did you ever read I, Robot?
Oh yeah, big Asimov fan.
I don't know if you remember, there's one story in I, Robot where, and I think this was part of I, Robot. Maybe it was another Asimov short story, but there's a guy on a space station and they're beaming energy or something down to the Earth, and they need to keep this energy directed at precisely the right thing. And then there's these intelligent robots that he's working with, and then he talks to the robots, and the robots are like, no, your memories are invented. Our memories are truth. We have a religion, and it's a matter of religious importance that the arc never drift more than like some, you know, a half of an arc second away, you know, this beam from the target. And I kind of view that as like, that's like harness engineering, where it's like, okay, the human, I mean, like the point of the story was more like, you know, how do you know if your memories are constructed, or, you know, you can't kind of know in the abstract. But
so the robots
it's interesting because
they were like implanted with, it's so important that this arc never waver, that it's a religion. And like that was the level of importance to them.
Well, right. And I don't know if a human did this intentionally or what have you. But the idea was like, or like you could imagine like a human found that the most reliable way to get these robots to like keep the beam in the right place was to actually create a religion for them. And it's it's like this religious fervor that they're using to.
It works pretty good on humans.
But yeah, so the takeaway is start a religion if you really want a good harness.
Yeah, and this segues nicely into this term ACI, which I don't know if Suleiman is coining this, but it's artificial capable intelligence. And I think his point is that we're sort of already there. And this, you know, this is sort of what I was trying to say with my earlier points about harnesses. It's like there's so much capability that we can already unlock.
Yeah.
By building these harnesses. And, you know, artificial capable intelligence, it may not be artificial super intelligence. It may not even be artificial general intelligence, but it's capable. It can do things. And that will, you know, provide an immense amount of value to humanity, hopefully.
Right. And I see this as, you know, Suleiman is really trying to sidestep any questions of, defining like, okay, what is AGI? Is it sentient? You know, is it conscious? He's kind of like, I don't care about any of those questions. If you're trying to assess its effect on the human economy or like human society, the answer to those questions don't really matter. What matters is what they're able to do. And if you're able to ask it to create a business that earns $1 million with $100,000 worth of input. Doesn't matter whether the thing on the inside is sentient.
Exactly. Yeah, there's real value there, regardless.
But yeah, this is his term. He coined this here, and I would like to coin a new term, AXI.
Xylophone
that's
intelligence?
Just everything. Artificial xylophone intelligence. Oh, that's right. Yeah, no, xylophone intelligence.
Wait, so sorry. AXI is all of these different types of intelligence.
It's everything. Yeah.
Nice. It sounds like an Elon Musk thing.
Oh, no. Yeah, because what is it? It's XAI, AXI. Oh, no. Yeah, maybe I'll stick with artificial xylophone intelligence.
I mean, I like that.
I'm okay with that. All right. Well, I think there's nothing more to say.
Nothing more to say
about intelligence. We did it all. AXI. It's everything.
Covered it.
Mic drop. All right. Well, next time. Ooh, I'm pretty excited about the next chapter. Technology of life.
Yes. Yeah. It's going to be cool.
Because I know nothing about life.
Yeah. We've talked about this before, but this book, I think, is going to cover a lot of AI, which we both have a background in. So it's going to be a little bit of a review. But the other half of this book is biology, and I'm very excited about that because I'm pretty much a layman when it comes to biology stuff.
Yeah, this is going to be good. All right. Well, I will see you next time for the Technology of Life.
See you next time, Matt.